Time-restricted eating, or TRE, is a very popular form of intermittent fasting that is said to have major health benefits. This video is the first of several in which we'll shed light on whether these claims are backed by scientific evidence. The topic of this first video in this series is the impact of TRE on body weight and composition, including visceral fat mass and liver fat content. My goal is that after watching this video, you'll have clarity on whether TRE can help you lose body weight, if TRE leads to a loss of body fat, which we want, or if it preferentially leads to a loss of lean muscle mass, which would not be desirable, and if TRE can help you get rid of some of the most metabolically unhealthy types of body fat, visceral fat and liver fat. Hello, and welcome to Nourished by Science on YouTube. My name is Mario, and on this channel I talk about all things nutrition as they relate to the prevention of chronic disease. Many of you will have heard about intermittent fasting and its supposed health benefits. There are many forms of intermittent fasting because intermittent fasting simply means that we consciously make an effort to avoid consuming calories for some extended period of time. The most common forms of intermittent fasting are time-restricted eating, of which OMAD, or 1 meal a day, is the most extreme version, alternate day fasting, or modified alternate day fasting, and the 5-2 diet. We'll talk about all of these at some point, but first, we'll thoroughly examine time-restricted eating, or TRE. We're beginning our examination of the health effects of TRE with a discussion of whether TRE can help us lose body weight. We'll also evaluate whether any weight we lose is mostly fat mass or lean muscle mass, and we'll look at whether TRE can be a valuable tool to get rid of visceral fat and liver fat, two of the most metabolically harmful types of fat in our bodies. What is time-restricted eating? In time-restricted eating, we make a conscious effort to limit our food, or more specifically our calorie intake, to a short window of time during the day. The most common forms of TRE use an eating window somewhere between 4 and maybe 10 hours, which means that then we fast for the remaining 14 to 20 hours. The most popular form is probably 16-8, where we eat in an 8-hour window and fast for 16 hours. Food intake always occurs during the day, and we do differentiate between early time-restricted eating, where all of our food intake occurs in the first few hours of the light cycle, and late TRE, where we may skip breakfast and eat all of our food in the afternoon and late evening. Several mechanisms have been proposed to explain why limiting our food intake to a relatively short eating window during the day may be beneficial. For one, TRE could help us align our circadian rhythm to the light-dark cycle of our natural environment and avoid a disruption of our natural circadian rhythm, which has been linked to numerous health problems. Second, there may be benefits to fasting for an extended period of time overnight. And third, it may be easier to prevent overeating and weight gain if we have fewer opportunities to consume food while we're awake. Well, let's get started by looking at the beginnings of this line of research. The impact of time-restricted eating on body weight in mice. It is interesting to start with one of the early studies in mice that got the whole world excited about TRE. In this study, researchers observed that if they feed mice a high-fat diet, they overeat and become pretty obese in just a few weeks. However, they also found that these mice liked the fatty food so much that if they had access to it 24 hours a day, they would constantly feed, even waking up frequently to do so. So they asked whether they could prevent this overeating and weight gain if they restricted access to the food to 8 hours per day. And indeed, the mice that could feed only for 8 hours a day did not gain nearly as much weight as those mice that had access to the high-fat food all day and night. Interestingly though, that was not because they ate less. The mice learned very quickly that the yummy food would be taken away from them, and so they just ate way more during the 8 hours they had access to it. To the researchers' surprise, they consumed as many calories as their neighbors who could feed 24 hours per day. So why did they not gain as much weight? Well, the researchers monitored the mice very carefully and found that the energy expenditure was a lot higher in the mice on 8-hour TRE, and that explained why they didn't gain as much weight as their friends, even though they ate just as much food. So the natural question is whether humans show the same response to time-restricted eating. In other words, do humans also gain less weight or lose weight on TRE even if they don't consume fewer calories? And that leads us to the first question we want to answer. Does time-restricted eating lower body weight independent of reduced calorie intake? Fortunately, we do have data from 2 high-quality trials in which participants were randomized to either TRE or a control group in which they ate in a normal eating window, and in which all foods were provided with a set calorie intake to keep body weight stable. Sutton and colleagues published results from a small study, but it was very well controlled and also conducted as a crossover design trial where each participant completed 2 dietary phases. In one phase, participants consumed all of their foods in a 12-hour window for 5 weeks. This was the control phase and is already a bit of a shorter eating window than how most people eat. But this is fairly close to normal. The neat thing about this study was that all foods were provided by the study team and all foods were consumed under supervision in the clinic. In other words, the researchers had exact control over when participants ate, what they ate, and how much they ate. Participants also completed a second diet phase, which also lasted 5 weeks. This was the TRE phase, during which they received the exact same amount and type of foods as in the other study period, but now they were asked to eat breakfast, lunch and dinner in this narrow 6-hour eating window early in the day. They then fasted 18 hours until breakfast the next morning. Each participant completed both diet phases in a random order. And even though researchers had planned to give participants enough food to keep them weight stable in both diet phases, participants lost a little bit of weight. 1.4 kilograms or 3 pounds on the TRE diet, and 1 kilogram or 2.2 pounds on the control diet. Now, and this is an important point to make, one thing that every single study in participants with overweight or obesity shows is that what motivates them to participate in a dietary research study is usually, at least to some degree, the hope that they will lose some weight. And therefore, we very often see participants lose weight no matter what the intervention is, even in the control group that doesn't receive a specific intervention. This is important because in this field of research into the effects of TRE, there are many studies that did not include a control group. And without control group, almost any intervention will look like it causes weight loss. Therefore, very importantly, we always need to compare the change in weight in the intervention group with the change in weight in an adequate control group. In this case here, that difference was not statistically significant. Well, you may say, but people in the TRE group seem to lose slightly more weight and maybe the study was just underpowered to detect this as a statistically significant effect. That is correct because only 8 participants completed both diet phases. The weight loss data by themselves are therefore a bit inconclusive. It is possible that this additional weight loss of on average 0.4 kilograms, almost a pound, over 4 weeks seen in the TRE diet phase could reflect greater energy expenditure as was seen in the TRE-fed mice. Fortunately, the investigators actually published a separate paper in which they reported energy expenditure data of participants on these 2 diets, and that number was almost exactly the same. So this is consistent with data from a second study that was somewhat similar but larger. This study enrolled 41 participants and randomized them to one of 2 diets, each of which was consumed for 12 weeks. One was an 8-hour TRE diet and the other a 12-hour control diet. So this was a parallel design study and every participant consumed only one of the 2 diets. Again, all foods were provided to participants and food and calorie intake were experimentally controlled. The way this was done is that the investigators calculated a number of calories that would be expected to keep every participant weight stable based on a formula that uses their body size and physical activity level. They used the same formula in both diet groups and participants had to consume all of the provided food every day, either in a time-restricted window or in the control group, more spread out over the entire day. Again, as in the first study, participants lost some weight, but it was about the same amount of weight on both diet arms. With just 2 studies, the evidence is a bit limited, but I think we can already conclude that TRE certainly does not have a huge effect on body weight that is independent of calorie intake, as was seen in the original mouse studies. Okay, does this mean that TRE does not affect body weight at all? No, not so fast. It only means that TRE doesn't seem to affect energy expenditure in humans, at least not in a major way, as it seems to do in mice. Next, let's take a look at what happens to body weight in people who adopt TRE if their calorie intake is not experimentally kept stable. Does time-restricted eating trigger weight loss? The first studies I'd like to show are randomized controlled trials in which participants were simply asked to eat either as they normally would, that would be the control group down here, or to eat only in a specific restricted eating window, that would be the TRE group up here. What all of these studies had in common is that no one was told to restrict their caloric intake. All they were told is to either follow TRE or not. This here is the list of studies I considered. I only considered studies with an intervention duration of at least 6 weeks because effects on body weight are difficult to detect in shorter studies, and I also only considered studies that compared changes in body weight in a TRE group to an adequate control group. There are actually many more studies that I gauged as methodologically too limited to consider here. I am critiquing each of these in the blog post associated with this video. As always, the link to the blog post is in the description box below. These studies varied widely in how much they restricted the eating window from 4-hour to about 10-hour TRE. But what they all had in common, without exception, is that following TRE made people spontaneously eat less food and fewer calories and lose weight. See here, the weight change was consistently and significantly higher in the TRE group than in the control group in all of these studies. That's the second conclusion we can draw here. Following TRE does help people lose weight, but not by increasing energy expenditure, but primarily by helping them reduce their calorie intake. Okay. So if TRE helps us lose weight by putting us into a caloric deficit, how does it stack up to the traditional approach to weight loss, an imposed caloric restriction? In other words, what do studies tell us in which people were randomized to either TRE with no caloric restriction imposed, or a control group in which people continued eating in the normal, much longer eating window, but where they were asked to count calories and only consume a limited number of calories? Well, we have 2 such studies of reasonable quality, and they both show similar weight loss resulting from TRE without imposed caloric restriction when compared to a control group with caloric restriction. In one of the 2 studies, the TRE group lost a lot more weight, but weight loss was highly variable in both groups, and so the difference was not statistically significant. Also, average weight loss was higher in the control group in the second study. So I'd say that the best evidence we have right now suggests that over 6 or 12 months, just adopting a time-restricted eating pattern without paying any attention to calorie intake has about the same effect on body weight as an imposed caloric restriction. That's actually really good news because it gives us options. I do think that for many people, TRE is probably a more appealing option to control calorie intake and body weight in the long term than continuous calorie counting and calorie restriction, which is hard for most people in the long run. Okay, so that leads us to the obvious next question, and that is whether adding TRE to a calorie restricted diet can help us lose more weight than with calorie restriction alone. These are clinical trials in which participants were randomized to a TRE diet in which they ate in a restricted eating window and where they also actively restricted their calorie intake, or a control group in which they ate in their normal eating window while also actively restricting their calorie intake. I have summarized those 6 trials of sufficient quality here in this table. Here we do get a bit of a mixed picture. 2 trials detected significantly greater weight loss with calorie restriction plus TRE compared to calorie restriction alone, while the other 4 detected no differential effects. However, let's take a closer look at some of the details. For one could argue that in many of these studies, the participants in the control groups actually exercised a mild form of TRE. See here where the average eating window in the control groups was around 11 hours or less in several studies, which is time restricted compared to the average eating window in the United States, for example, which is around 15 hours per day. So this alone may have limited the ability of these studies to detect an additional effect of TRE. Further, in the study by Thomas and colleagues, the difference in the eating window between the TRE group and controls was barely more than an hour, which may simply have been too small. Despite these limitations, the absolute weight loss was actually, on average, greater in every single one of these studies, so it also stands to reason that some of these studies were simply underpowered to detect the additive effect of TRE on weight loss in populations that were already losing weight due to the imposed calorie restriction. I have discussed this point in much detail in a previous video about that last trial listed here by Lou and colleagues. You'll find the link to that video in the description box below. Taken together, I actually would cautiously interpret the available evidence as suggesting that adding TRE to calorie restriction might modestly enhance the weight loss. My best guess is that TRE may simply make it a bit easier for people to maintain a caloric deficit over an extended period of time. To conclude this part of the video, just restricting food intake to a window of 4 to 10 hours per day consistently leads to spontaneously lower calorie intake and weight loss, whereas it does not seem to affect energy expenditure, at least not meaningfully. The effect of TRE on calorie intake and weight loss is similar to that of an imposed calorie restriction, and there may be a modestly greater weight loss when TRE is added on top of an actively calorie-restricted diet. With that, let's move to the next part, and that is, does time-restricted eating primarily reduce fat mass or lean mass? What I'm interested in here specifically is if people lose weight on a TRE diet, do they lose mostly fat mass, which is what we want, or do they preferentially lose lean mass, meaning muscle mass? There have been some rumors that TRE causes more muscle loss because of the extended fasting period, and I agree it's important to understand whether the weight we lose on any intervention is actually body fat or muscle. Let's look at the available studies again that measured changes in fat and lean mass in the same categories as above. We'll start with those studies in which participants were randomized to either TRE or control without imposed caloric restriction in either group. By and large, what most of these studies show is that people who follow a time-restricted eating plan and spontaneously lose weight lose mostly fat mass. That's what we want, which is why I have shaded these studies here in green. Feel free to pause the video if you want to verify this yourself. For example, look at these longer-term studies here at the bottom. In Pavlou et al., participants lost an average of 4.5 kilograms over 6 months, which is almost 10 pounds, and about 2/3 of that weight loss was body fat. Even better here are the data from Lin et al. In this 12-month studies, participants lost almost only body fat and barely any lean mass. Basically, in all of these studies, the percentage of weight loss that was actually lost as fat mass was similar or better in the TRE group when compared to the control group. However, there are 3 studies in which participants experienced a substantial loss of lean mass as they lost weight on TRE. An extreme example is the study by Brady and colleagues, in which participants lost a very modest amount of weight, and most of that was lean mass. But even in the other 2 studies, there was about as much loss of lean mass as of body fat. That's not particularly desirable. Okay, next we have 2 studies in which TRE was compared to a calorie restriction control group. This data suggests that the degree to which we are losing fat versus lean mass with TRE is similar to what we see with a calorie restricted diet. And lastly, let's look at those studies that investigated the impact of TRE when added to an already calorie restricted diet. So this is calorie restriction compared with calorie restriction plus TRE. And in these 6 trials, there was not a single one that suggested a more significant loss of lean mass relative to the total weight loss in the TRE group compared to the control group. In all studies, fat mass accounted for at least 2/3 of the total body weight lost, which was similar or better than what was observed in the control groups that followed calorie restriction only. I'd like to highlight 2 particular studies that are relevant in this context. For one, take a look at this RCT by Stoat et al. Here. These investigators had participants complete one 8-week period where they just ate 1 meal a day, which is nowadays often called OMAD. They gave them 4 hours to complete this meal. So participants were fasting for at least 20 hours per day. This was a crossover design study, and they had each participant also complete an 8-week control period where they ate in their normal eating window. This design is particularly powerful because it allows us to compare each participant to themselves. An additional strength of this study was that all foods were provided and partly consumed in the clinic under supervision, so this was a well-controlled study. And these data show very substantial loss of body fat, 2.1 kilograms or 4.6 pounds, whereas lean mass increased quite substantially. I'm honestly not sure why lean mass increased here. There was no exercise program included in either phase, but the main point I wanted to make is that TRE, even an extreme form of TRE such as OMAD, does not automatically lead to a loss of lean mass. The second study is this one here by Morrow and colleagues. This was a parallel design study in which participants were randomized to TRE or a control diet where they ate in their normal eating window. In addition, all participants completed regular resistance training. And what we see here is that while the overall weight loss was modest, they lost mostly body fat and even tended to gain lean mass. This increase in lean mass was the same in the control group because both groups exercised. But the key point here is that, as in any weight loss program, engaging in exercise and particularly resistance training could be a very effective way to make sure you hang on to your muscle mass when losing weight on TRE. Taken together, if we consider all of the available evidence, we can conclude that about 2/3 of weight lost on TRE is body fat in most studies, which is similar to what we see in calorie-restricted diets. We do not see any evidence that TRE somehow leads to a greater reduction in lean mass, which is reassuring. Nevertheless, a recommendation would be that if you follow any form of TRE, or any other weight loss program for that matter, that you engage in some form of resistance training regularly and keep your protein intake high to minimize any loss of muscle mass. With that, let's move on to the last portion of the video where I'd like to take a look at what type of body fat is lost in TRE and whether there is a particularly strong effect on the types of body fat that matter the most for our long-term health: visceral or intra-abdominal fat, and liver fat, a type of ectopic fat. Does time-restricted eating lower visceral fat and liver fat? I'd like to start by sharing the data from a high-quality trial that looked at the impact of TRE on visceral and liver fat. This trial here by Wei and colleagues was published last year. They enrolled 88 participants who suffered from both obesity and non-alcoholic fatty liver disease, or NAFLD, and randomized them to either restrict their calorie intake every day for an entire year, that was the control group, or to restrict their calorie intake and also follow 8-hour early time-restricted eating, with food intake only between 8 a.m. and 4 p.m. Now, one of the primary factors that is linked to elevated visceral and liver fat is excess body weight. So let's first take a look at what happened to body weight and fat mass in this study. Given that participants in both study groups were actively restricting their calorie intake, we would expect them to lose weight. And indeed, in both groups, participants lost about 10 kilograms or 22 pounds at 6 months and about 8 kilograms or 17.6 pounds at 12 months. And that degree of weight loss was very similar in the two groups, with no additional weight loss in those who also followed TRE. Most of that weight loss was due to a loss of body fat in both groups, and in this particular study, we didn't see any hint of an additional benefit from following TRE in the context of a diet that was already calorically restricted. So both groups lost a similar amount of weight and body fat. How about visceral fat? As we see here, both groups lost visceral fat, and the reduction in visceral fat was highly significant in each group. See how the 95% confidence intervals do not include 0 here? However, in this study design, the more important comparison is whether the change from baseline to the 6 and 12-month time points differed between the two groups. And this was not the case for either time point. In other words, just like the reduction in body weight and overall fat mass, the amount of visceral fat lost was similar in the two groups, meaning it was mostly driven by the caloric restriction and there was no additional benefit from following TRE. What happened to liver fat content? The liver fat content of these participants at baseline was about 13.5%. In healthy people, the fat content in the liver should be 0%, and whenever it is 5% or higher, we call this fatty liver disease. Well, let's see what happened as they restricted their calorie intake with or without TRE. This graph shows the absolute change in liver fat in both groups. In orange are the data from the TRE plus caloric restriction group, and the data of the control group that only followed caloric restriction is shown in blue. We see that 6 months into the intervention, the liver fat content is reduced by an average of about 8 percentage points, meaning it was reduced from an average of 13.5% to around 5.5%. And that reduction was very similar in the two groups, meaning that whether participants followed TRE had no impact. That would strongly suggest that the reduction in liver fat was primarily driven by the reduction in calorie intake and the weight loss. See how the weight dropped mostly in the first 6 months of the trial and then stabilized or even rebounded a little. And we see this exact pattern mirrored in the liver fat data. This is just one trial, but it's a good one, and these data would strongly suggest that both visceral fat and liver fat are primarily responsive to caloric restriction and weight loss, and that TRE does not offer any benefit beyond that. For liver fat, this conclusion is supported by another crossover design study of 10-hour TRE versus control in patients with type 2 diabetes who averaged about 9% liver fat at baseline. In that study, participants were experimentally kept weight stable, and in that setting, liver fat content did not change. In other words, adopting a time-restricted eating pattern does not by itself have any impact on liver fat content if the weight is being kept stable. For visceral fat, there are a few other trials that give us some insight. In general, what they suggest is that significant reductions in visceral fat are driven by overall weight loss, but that TRE does not lead to additional reductions in visceral fat beyond this effect on weight loss. For those of you who are interested in more detail, I've discussed the individual studies in the blog post. Link is in the description box below. So, to conclude, pretty comprehensive evidence for visceral fat and limited evidence for liver fat suggests that reductions in these metabolically very damaging fat compartments are driven entirely or almost entirely by changes in the overall body weight. In other words, TRE doesn't seem to have any impact on visceral fat and liver fat, independent of any impact it has on overall body weight. Therefore, it would be my assumption that if you had excess liver and visceral fat, and you adopted TRE and it helped you lose some weight, that both liver fat and visceral fat would be reduced. And the more weight you lose, the more visceral fat and liver fat you will likely lose. Which form of time-restricted eating is best for weight loss? We can categorize TRE based on the length of the daily eating window and also based on when in the day that eating window is. The question is, do these things matter? In terms of the length of the eating window, most studies used windows from 4 hours to 10 hours. We don't have a lot of studies that have systematically compared, say, 4-hour TRE versus 8-hour TRE. But from those studies that we do have, and just generally looking at effect sizes across studies, I would say that it doesn't matter too much as long as you reduce your eating window meaningfully from what you are currently doing. As in, if the current eating window is 11 hours, I wouldn't expect much of an effect from adopting a 10-hour TRE. In TRE, we also differentiate between early TRE and late TRE. What we mean by this is if you do, say, 16-8 TRE, where you eat in an 8-hour window and fast the remaining 16 hours. You could be eating between 8 a.m. and 4 p.m., for example, or between, say, 12 noon and 8 p.m. One is commonly called early, the other late TRE. Does it matter when it comes to how much weight or fat mass we lose? As I was reviewing the data, I couldn't detect a specific pattern, and this was consistent with a recent meta-analysis that came to the same conclusion. My general suggestion would be that if you want to try TRE, pick something that you can happily sustain for an extended period of time. Because if you say, try 8-hour TRE for half a year and lose some weight, you are probably going to regain that weight should you adopt your typical longer eating window again. Similar to when you go off a calorie-restricted diet. So in the interest of giving yourself a chance to reduce your body weight and improve your health over the long term, pick the form of TRE that is feasible for you and that you enjoy enough to do it over the long term. I, for example, have loosely followed 10-hour TRE for probably 7 or 8 years. I don't stress out about it and will make exceptions if there's a party or if I'm really hungry. But I would say that I roughly eat in a 10-hour window most of the time. And to me, that's an almost effortless way to prevent overeating and weight gain. Summary and conclusions. Okay, let's summarize everything we've learned in this video. First, in humans, TRE does not meaningfully increase energy expenditure. Second, restricting the eating window leads to a spontaneous reduction in calorie intake and weight loss. Third, the weight loss achieved with TRE is similar to that typically seen in people who are actively restricting their calorie intake. Fourth, adding TRE to a diet that is already actively calorically restricted may lead to a modestly greater weight loss. Sixth, TRE-driven weight loss is not associated with a greater loss of lean mass than other forms of weight loss. Seventh, TRE does not seem to offer any additional benefits for reducing body fat, visceral fat, or liver fat beyond its impact on calorie intake and weight loss. And eighth, with regard to weight loss, the specific type of TRE, that is early or late TRE, or how long the eating window actually is, does not seem to matter too much, as long as the individual eating window is sufficiently reduced and is somewhere in the 4 to 10 hour range. Okay, that's it for this video. I hope this will provide valuable guidance if you want to try TRE. If you appreciate the information, I would be grateful if you could click the like button and share the video with anyone you think may be interested. In our very next video, we will cover the impact of TRE on cardiometabolic health, including blood sugar regulation and insulin resistance, the fasting lipid profile, and blood pressure. Again, you can find a link to the blog post with more detailed discussion, as well as all of the very numerous scientific publications in the description box below the video. Thank you for watching. Take care.